All right, here we go, day 6. All right, this is a little bit of a longer unit. So today we're going to talk about how to solve exponential equations that you cannot create a same base. All right, so when you can create a same base, you can do it without a calculator. Today we are going to need to use that calculator. All right, so the first step is that you need to rewrite the equation with one term on each side. So you cannot have multiple things on each side. The next is that you're going to take the logarithmic function, all right, to undo the exponential function, which that means you're trying to do the inverse. So you're trying to get rid of that exponential. And then you're just going to solve the resulting equation. So I'm going to go ahead and do 1 through 6 in this video, and then you guys are going to do 7, 8, and 9 tomorrow in class. If we were to look at this first one, the first step is always, can I rewrite one as the other? You cannot rewrite 30 to be 3 because 3 raised to the third power is 27. 3 raised to the fourth power, that's 81. Like, you're never going to get that. So this is an example where you'd have to use the calculator. So we're going to rewrite this as a log. We have one term on this side, one term on this side. So we're going to say this is log base 3 of 30 is equal to x. Once you have that your whole log is equal to your x value, then you can plug it into your calculator. So in your calculator, you have a log button, all right? But to get there, you have to do Control 10 to the x, and you get this log button. You can do 3 is our base, and 30 is our argument. Enter, and then it's telling us to round to the nearest thousandths. So that's 3 spaces. So this would be that x is about equal, because we're rounding, to 3.096. All right, so let's do the second one. All right, second one, rewrite the equation with one term on each side. Well, right now that left side has 2 terms. So we can't go straight into writing our log. We need to move this 4 first. So we're going to add 4, add 4. 10 to the x is equal to 38. Can I rewrite 38 or rewrite 10 so that they have the same base? The answer is no, you cannot. So you're going to go ahead and you're going to write log base 10 of 38 is equal to x. And then again, that's going to go in your calculator, all right? So practice writing it one more time in here. This one is going to be Control Divide. This is a base 10. 38 is our argument. Enter. We get 1.57978. So if we tried to round to the nearest thousandth, this 9 would get rounded up. So we would end up getting x is about equal to 1.58. All right, next one. So again, one argument, we need to move this 14 over. We cannot have more than one term on each side. So we're going to get that 5x is equal to 7. Can you rewrite to have common bases? No, you cannot. So this is going to be log base 5 of 7 is equal to x. If we plug that in our calculator, we're going to get that x is approximately equal to 1.209. So those are our pretty simple ones. All right, so now let's bump it up one level. So if we were to bump this one up, all right, this should be a 1/2. We need to move our 4. So subtract 4, subtract 4. 3 times 1/2 raised to the x is equal to 15. Divide by 3, divide by 3. 1/2 x is equal to the 5. Can I rewrite one to be like the other? The answer is no, you cannot. So we're going to go ahead and rewrite what we have. So now we're going to have log base 1/2. That's fine. It just can't be a negative number of 5 is equal to x. That's going to end up giving me that x is equal, or approximately equal, to negative 2.322. Now, I have been saying no negative numbers. You can have negative exponents, you just can't have negatives inside your log. So we had a positive 1/2, we had a positive 5, that's fine. We can get a negative answer as our exponent. All right, next one. We already are isolated, so we can go straight into writing as a log. So this is going to be log base 2 of 3.6 is equal to 4x. You could solve this in your calculator, see what you get, and then divide, or I know I'm going to have to divide by 4, then I can write all that in my calculator at one time. So if I was going to write all that in my calculator at the same time, I would go ahead and do control divide, so I get my big fraction, and then control log base 2 of 3.6, all divided by 4. Enter. You're going to get about 0.462. So we're going to get that x is about equal to 0.462. All right, then the last one we're going to do in class is going to be number 6. So number 6, again, you already have just one argument on each side. So we're going to rewrite. We're going to be log base 19 of 3 is equal to x plus 4. Again, you can go ahead and do that, or like solve this as a piece and then subtract 4 at the end. Or we know we're going to have to subtract 4, We're going to have log base 19, 3 minus 4 is equal to x. We can type all that in your calculator. When you type all of that into your calculator, you're going to get that x is equal to negative 3.62. Again, fine if that's your final answer, just can't ever have x's inside your log. All right, 7, 8, 9, we're going to wait on those. 7's definitely the big dog problem. 8 and 9, you would do the same way that we've been doing, but instead of using the log button, you would actually use this ln button. So you would use control divide to get that natural log so that you have, because you have base e. So if you try to do those at home. All right, you guys are almost done, close to the end. See y'all tomorrow.